Welcome to the sixth lecture of Gravitation chapter of class 7. I am Abhimanyu Singh, first year student at IIT. We will be mostly solving problem in this lecture. And as we have done in the previous lecture, we presented some of the we presented selected problems from various books and previous year questions and like so. I will all be presenting the questions and reading out them. I encourage you to try them on your own. And in case you face any problem, you see the solution, you try to learn from it, and then retry it. Unless you will not, you need to try physics. If you don't try, you will not able to learn it. It is not like chemistry; you can just memorize it. It's about understanding the concept. So to understand the concept, you need to apply it. So I encourage you to like attempt the problems on your own at first, then move for the solution. And if you are attending this class live, I will be giving you few seconds to like attempting the problems. But as there is no one, I will be continuing. So I have so let's start. This is like so let's start from the first problem. Okay. Let me introduce what is the problem. Okay. Let me read out the problem. A spaceship is sent to investigate a planet of mass m and radius r. While hanging motionless in space at a distance 5 far from the center of the planet, the spaceship fires an instrument package of mass m, which is much smaller than the mass of spaceship. The angle theta for which the package just grazes the surface of the planet is like. Let me explain the problem for you. So let us start by explaining this problem. I will erase it. Suppose this is like the spaceship and it is at distance. This is 5 r distance. Okay, m comma r. Okay, now it flies the instrument of mass m, like it anything m, and with v naught velocity. It is given. This is like this. This can go like this. This can go like this. Suppose if you throw a particle from here, what will happen? If there is no force, it will go in straight line. No issue, just in straight line. F is equal to 0. But as you know, solid mass like planet have gravitational field. So the gravitational field will be attractive in nature. So it will be turning its path toward it like this, and it will be entirely random. Like it will mostly it can attract or like the direction is different. It is like this. It is like this. At every plate, the direction and magnitude varies. So it is like this. It is quite arbitrary sense. So like, how do we move forward this problem then? So as you can see, everything is arbitrary. So when like in case, let me again draw a nice diagram. And let me change the color of my pen for the diagram. M 5R. This is the planet, and here the mass is thrown like and at angle theta. It is all are straight line, no curve with a velocity v naught. Okay, this is center. This is say point P. Now, if it says it is just uh, one of the most important point for this problem in this line, grazes. What does grazes means? Grazes means it whenever it goes, it just touches the planet. Like uh, grazes word implies if it falls, then it like this. It will be like this. It will be falling like this. It could also fall like this. But grazing means it is going somewhere like about the tangent and this. Okay. I hope you understood. Okay, this is the image. Now let me write this on. Let me do the solution. I encourage you to try this on your own. Grazes implies when it touches the planet the velocity is tangential. Let me assume the variables. Uh, Let the final velocity at the time of grazing be v. So bv when the forces, direction, and magnitude changes continuously, we should use conservation laws. So we will be solving this problem using conservation law. As you know, what are the common types of conservation? First is like momentum conservation, which is I don't think is valid in this problem. What is the condition for momentum conservation? Force zero implies P conserved. Torque zero implied L conserved, which is angular momentum, or energy conservation is there when there are no non-conservative force. So what can we do in this problem? We know that force is not zero. Force is not is equal to zero. So this will not happen. But in central forces, F cross R, which is like the direction of force in radial direction, so the torque is zero. That implies we can use this. And there are no heat, no friction, heat, friction, nothing is there. So we can apply this as well. So now we need for applying these two conservation laws. Okay. First we will be doing First we will be doing angular momentum conservation. So how to do it? For this we will be needing the diagram. Okay. Like what happens initially? Initially, what is the this is mass m. This is at distance 5r. So for angular momentum, we need to decide about which point we will be conserving angular momentum. Which point? It is obvious. We will be using center of planet. Why? Because force is zero about this point. You can use any point, but the choosing of variable will be more and more tougher. Like you need to find the distance, you need to do some geometry. Always like choosing a center makes our work easy. So we are choosing that point. Okay. So now initially what we have? Initially we have like it is at distance 5r, and what is the perpendicular velocity of to it? If we break it, here it comes out to be v naught cos theta, and the perpendicular direction it comes out to be v naught sin theta. So like what is the formula of angular momentum? L is nothing mv perpendicular r, which is v perpendicular means uh, a velocity perpendicular component of velocity perpendicular to the position vector, which is nothing but v sin theta. And what is the initial distance? It is 5r. L initial it is. And what about L final? So L final is like we know that the velocity is like this. So what is the angle? Angle is 90. So every component is there is no non-perpendicular component of v in the final scenario, and the distance is nothing, just r. So we write as L final as m. Okay, it is v naught sin theta, vr. Okay, now L initial equal to L final. What we will do? M v naught sin theta is equal to 5r m v r. R gets cancelled. M get cancelled. V is equal to 5 v naught sin theta. So this is the answer. Now we will be like applying energy conservation. Energy conservation is like quite simple to apply. How to apply it? We will be just equating the final energy by initial energy. So E initial is equal to E final. How do we do it? What is the kinetic initial energy? Half m v naught square. What is potential energy initial energy? It is just a square, so it will be minus GMM by 5R. What is the final kinetic energy? Let me wait. Can I copy this calculation? Okay. So E initial is nothing but half mv naught square minus GMM by 5R is equal to half capital M V square minus GMM by R. So doing the calculation, we get GMMR 1 minus 1 by 5, which implies 4 by 5, is equal to half M V square minus V naught square. And let me put the value of from equation 1, half M V 25 V naught square sine square theta minus V naught square. So what does it came out to be? GM 4 by 5 R is equal to half 24 V naught square sine square theta. So it will get 12. We will get like 3. So 15. GM, GM by 15. So 5 3 are 15. GM by R V naught square is equal to sine square theta. So, so sine theta is nothing but root under GM by 15 R V naught square. I have, I did some error, I think. Let me relook at the calculation. This is correct. This is correct. Now, this is correct. This is also correct. This is also correct. Uh, this is, I think, is correct. Okay, how can I do? Oh, I did it. Very- Let me erase what I did wrong. Let me show you what I did wrong. I did a silly mistake. You can also do it. I just like half M25 V naught sine square theta minus V naught square. Let me erase this. How can I do this? This is silly mistake. So just cut this M. So we have 8 by 5 GM by R is equal to 25 V naught sine square theta V naught square minus V naught square. So let us divide both sides by V naught square. So we have like 8 by 5 GM by R V naught square plus 1 25 sine square theta, taking square root on both sides. We take only the positive value of theta. We don't assume like theta is over 90. So we will be getting like 5 sine theta is equal to root under 8 by 5 GM R V naught square plus 1. So theta is nothing but sine inverse 1 by 5 8 GM R V naught square plus 1. This is the answer. Let me rewrite the answer in a better manner with a different color. Theta is nothing, so that you can resolve. When you solve the problem, you easily find this. I encourage you to like resolve these problems because these will help you solve building your basics. If you are not able to get it in first try redoing it because these problems will really help you. So this is the final answer. So this problem just involves like understanding what you need to do and then just applying the concepts. So I hope you understood this problem. Now we have the second problem. Like what is the problem? Uh, A tunnel is dug along the chord of non-rotating Earth at a distance r by 2. Okay, the distance d is r by 2 from its center. A small block is released from the surface of Earth. The block comes to rest. Release. Release means v is equal to 0. U is 0. So also, like u is also 0. This point, the velocity also becomes 0. Do you know why it like moves? Because there is like a force which is attracting, so it will start moving, moving, moving. But there is friction, so it will stop it moving. Like suppose in between, this is at an angle theta. What happens? Like there is in this direction there is gravity force Fg, and Fg ka sin theta is like pulling it here. Fg ka sin theta is pulling it here, and mu n is pulling it here, and like normal is there, and like Fg ka cos theta is balancing the normal, and Fg ka sin theta is like this. So this is the scenario. Okay, what is happening? Now we need to calculate the value of heat. What we need to calculate? Like first is work done. Work done is simple. Work done is nothing. Okay, the second part is like nice. So work done is like very easy. So let us start this problem. Uh, Let me draw my own diagram. It will be better for you to understand. This is the Earth. This is like center. This is the sphere. So like we have the distance d here. So here the particle is like this. So let us assume any position theta. Okay, there is no enough space to draw the FBD. I will draw. I am drawing the FBD here. Actually, I'm just drawing the tunnel and drawing the FBD. Nothing else I'm doing. This is the center. This is the center C. Okay, like this is the block. So at an angle theta, this is the radius. So this is FG. So what is the value of Fg at this point? It is nothing. It is like G mass of Earth into R by 2 by R cube. What is come out to be? Gm R square by 2. This is the value of Fg. Now for like let me draw the FBD and let me draw the rest of the force. So what will be the here? Here will be Fg cos theta. My here will be friction as it is moving. It will be mu n, and here it will be Fg sin theta, which will be being balanced by the normal. This is like it is not the case. It is the case at the center. The other place, the distance from the center is different. So obviously this Fg is not close. So let us do the first part of this. Like let us calculate the work done by friction. So what is work done by friction or heat raising? They can ask in two ways. Like they can say work done by friction or heat. It is nothing but the total change in energy or the loss in energy. Loss in energy. In this case, as K initial is 0, as it is released from rest, and K final is 0, it is nothing but U final minus U initial. I'm just talking about the modulus. It will be obviously negative in the negative. So like, let me write U initial. What is U initial? It is just a particle at the surface of Earth. So it will be like GMM by R. And what is the U final? It is nothing but minus GM by 2r cube 3r square minus r square. This is important formula to know. So you need to like put the value of r here. U final is minus gm 2r cube by 3r square minus what is the distance from the center? It is just r by 2. It is nothing but 4 3 12. Okay, it is so it will be 4 3 11. 4 3 12 minus 1 11 r square by 4. What it will be? It will be minus gm by 4 to the 8 r 11 by 8 gm by r. So delta u is nothing but minus 11 by 8 r plus gmm by r. So it will be nothing but minus 3 by 8 gmm by r. It will be the work done by friction. Now, as it is work done by friction, we know that work done is nothing but force into displacement dot product. So it will be minus 3 by 8 gmm by r. This is the total work done. What is the value of the force? It is nothing equal to mu n. And what is the distance moved? What is the total displacement? It is like you can do the geometry. Like n is along this direction and all the displacement along this direction is this is r, this is r by 2. So this comes out to be r square minus r square by 4. That is like 4r square minus 3 root 3 by 2r. Displacement is 3 by 2r is equal to minus 3 by 8 gmm by r. Now we need to find the value of n. So using FBD, we know that n is equal to force of gravity sine theta. Let me do it on the side. And it is important. We have also done a similar problem in the classroom. Like, for normal. Normal is nothing but Fg sine theta. What is gravitation? Gravitation force is nothing but minus Gm. What is the field inside like sphere? Distance from the center m x, that is distance from center, and r cube into sine theta. What is x? X is nothing but r by 2 sine theta. So it came out to be gmm by 2r square. So like normally actually, so mu, let me continue this problem. Mu into gm m by 2r square is equal to root 3 by 2r is equal to, there will be a negative sign and the negative get cancelled. 3 by 8 gmm by r. This get term, entire get cancelled, 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 cancelled. Doing the calculations, we get like 2, 2, here we get 2, root 3 by 2. So like one of the most crucial part of this problem is like finding n. This is a nice problem, I will say. It involves like multiple concepts. First is about like how can we find like heat energy, frictional energy. The second is about like the second problem involves around work power energy. It also finds about that. It also told us that also one point to be noted. I also have made you note about in the lectures, but let me write it again. Normal is just mg by 2. If you see, it is constant always in this problem. wherever you go in the tunnel. This is important. This can be utilized in examinations. In this case, obviously mg by 2 is not the value, but it can be like, it is always constant, whether it will be mg by 3 or mg by 4, but it will always be constant. So now let us move to the next problem. So this is a very nice problem. This was one of the fundamental problems. It is from Erodo. So let me show you the analysis. Okay. So okay, let us say what is a twin star system? There are two stars. This star is like M1 mass, another star is M2 mass. They are at separation D. Okay, so they are each moving around each other in their own field. So we will be like, uh, so they are moving in their own field. There is no other external component. So for doing it analysis, one of the like common ways like assuming a equivalent mass system. But I would prefer to do it in like a more fundamental method. So this is at distance D. What we have the information like M1 plus M2 is equal to capital M, and time period is twice M. Okay. What we need to find the distance D. Okay. Each has a radius R1 and each has a radius R2. Like using the gravitation law, what is okay G M1 M2 D square is the force by which it is rotating. This is a gravitational force. Due to this, mass is getting a centripetal force to get rotation in a circle. So this is like this, and m omega square r. Let us say it is the radius. It is the path of the orbit. This is the way I have solved it. I know you didn't understand anything. Let me explain it. So, like there are two particles. It is here. So there are two particles, M1 and M2, obviously. So they are just applying force on each other. Like M1 is pulling it this way, M2 is pulling it this way, and the net external force is zero. So like center of mass of this system must remain is zero. CM must at rest. That implies the stars are revolving around the center of mass of the. So let me give you a more clarity. M1, M2, R1, R2. We know that the formula of center of mass is nothing, sigma mi ri by capital M. So what will be like, suppose this is the origin. Suppose this is the origin. What will be the distance of center of mass from it? It will be nothing. It is at origin. So M1 D, which is the D is the common separation between these two. This is like positive direction. So this distance will be M1D plus M1 plus M2. So now applying Newton's law on M2, sigma vector F external is equal to MA. So what is the force? Force is nothing. G M1 M2 by D square. What is the expression? M2 omega square, which is 4 pi square by T square into which is R, which is distance from the center. So it is M1D. This is the same thing I have just done. On solving this, we came out to be this came out to be g m t square 4 pi square 1 by 3. Like this is the problem. This is not the problem. It is a similar problem. It is just like it was asked recently in JEE Advanced 2021. So I will be solving this problem. So what does the problem say? The distance. Let me explain the problem first. Then we will solve it. So the distance between two stars is 3 mass of sun, 9 times mass of sun is 9R. What is R here? R is nothing. Ms is mass of, and it is a mass of Earth, and it is R. Now we need to find, like we have still found it, like the time period D is nothing. The distance between a twin star system is nothing by T square by 4 pi. 4 pi square 1 by 3. So it is we can apply this formula directly. You can memorize it if you want to. Like what is D? D here is 9R. What is G? G here is G. M is M1 plus M2, which is 12 times mass of S. What is T? T we need to find. Tn we need to find. And we have like 4 pi square 1 by 3. So 3. On cubing both sides, we get 729 R cube, which is equal to 3 times G ms Tn square by pi square. Oh, sorry, it will be 9. Sorry, it will be 9 and 4 will stay there. It is like 6 and 3. Okay, and 9 will go there. It will get 81 and we will solve it. 324 R cube pi square GMS Tn square. Tn comes out to be 18 root under R square R cube pi square G time mass of sun. In the second case, what is the time period? It is just simple case. 4 pi square R cube G time mass of sun. This is it. So we just segregate. So we get Tn as 9 times Ti. So what does n come out to be? N came out to be 9. Simple problem. Now, like, so I think we should end the class. Okay, sorry, one problem is left. Okay, okay, this is a nice problem. This was a problem from J. It was asked in like 15. So we were doing the solution. Suppose in equilibrium, suppose there are multiple spherical layers. This is like spherical fluid and another layer, this is thin radius R, another layer dr is being built up. Okay, so it will be get attracted towards the system. So to balance it, there is an external pressure which rises. So it will be like it is here P, it is here dp, P minus dp, because we apply pressure from high pressure to low pressure. So here dp balance out the force due to gravitation. Okay, and let us say what is force due to gravitation? G m m x by r cube. Okay, now suppose This is like dp into a. Sorry, dp doesn't want to. dp into a is balances force due to gravitation. So dp, what is the area? Area is nothing but 4 pi r square, where r is small r. Gm, what is m? dm, it is like 4 pi r square dx rho into x by r cube. This and this get cancelled, and doing the integration, we get some constant k into a square minus r square. So we came to know that at a r is equal to 0, p is not equal to 0, but r is equal to r, p is 0. I hope like this is it for today's class. I think this concludes gravitation. We can do still one more concept. We haven't covered like something called self energy. Just I will build up a simple example and complete this chapter. What is self energy? Required to build an configuration of mass. Energy required to build an configuration of mass. Whether it's a sphere, it's a shell or anything. Like suppose this is like a sphere. As we have seen in the previous question, there is a force which helps in building it. So we face, as we have some initial charge, initial mass, we bring some more mass, it gets supported, it gets attracted, we can easily assemble it. So this this is known as self energy. This extra energy is known as self energy. How can we calculate it? So the calculation formula is simple. E square deta is the energy, where deta is nothing but volume integral. Volume integral. This is like a general formula. You can also do it like by via basic concept. You just like build up one layer, then build another layer of concentric layer dx and integrate it over the wall. You will get the answer. So like you can read more on self energy, but this is like just for the sake of completeness. This is not much needed. So I think this concludes the chapter of gravitation. So thank you.